In this short video, we're going to use PICWave to model a quarter wave shifted DFB laser. In the simple model we have in front of us, we have the two gain waveguide sections that make up the DFB laser. And clicking on them, we've discovered the length is 160 microns each. And they both have the gratings with a grating period of 235 nanometers. This right-hand side section has a phase shift of 180 degrees for a quarter wavelength shift. We have two monitors, one on the left, one on the right. And we have a current signal, which is essentially a ramp up from 0 to 200 milliamps over a length of 100 nanoseconds. So we can run the simulation from the TD-TW calculator for 100 nanoseconds. And what we see here in the blue line is the Li curve just appearing. And once the simulation is over, we'll click the Inspect button to have a look at some details. So let's go to the Spectra tab and plot the spectrum versus time. And we'll click Plot. I'm just going to put this on the 2D view just to make it slightly easier to see. And you can very easily see that above threshold of around 20 nanoseconds, we have a dominant laser line. So let's go to the Li Fit tab. And quite simply, all we need to do is run fit and plot. And what we've done, we've fitted a line to the Li curve so that we can understand some statistics. So what we're seeing here is that the threshold current is around 47 milliamps. And the differential quantum efficiency, 0.384. Other things we can look at is if we just come out of the Results tab, we can highlight both sections of the DFB, right-click, Z profile, mode power. And this shows us along the cavity axis the power in the mode with a maximum, a peak in the center, which is quite typical of DFB lasers. And then if I right-click again, but this time select Active Layer Data, I can look at the carrier density along the cavity axis. And you can see here the longitudinal spatial hole burning and the fact that it corresponds to when we saw the peak of the mode power in the center, we get the opposite in this case, which makes sense.